Today's lesson is going to be a review on how to solve linear systems algebraically. So yesterday we did graphically, which is we figured out how to graph two lines and then find where they intersect, and that intersection point is the solution. So today we're still going to be looking for the intersection point, but we're going to be doing it algebraically, and there are two methods that you should remember from before. One of them is the elimination method, and the other is substitution. So with the first example that we have, our two equations are 3x plus y equals negative 21, and x plus y equals negative 5. And what we're going to do here is figure out, do we want to use elimination or substitution? So either will work. In this particular case, I think it would be really easy if we did elimination. So in elimination, we need to figure out, do we want to eliminate the x's or the y's? So which one would be easier? Now personally, I think the y's would be easier because in order to eliminate these, when we add them, we just need to make sure that we have a positive and negative version of the same x or y value. So since we both have positive y's, all we need to do is make one of those y's negative. And to do that, we can just multiply the entire equation by negative 1. So the top equation I'm not going to change. That's going to stay the same. So that's going to stay as 3x plus y equals negative 21. The bottom equation, though, that's going to change to, when I multiply every single term by negative 1, it makes that a negative x, a negative y, and a positive 5. And what we're going to do next, since this is the elimination method, we're going to add these two equations together. And when we add them together, you should notice that the y's are going to eliminate. That's why we call it the elimination method. And then when we add 3x and negative x, we should get 2x. And when we add negative 21 and 5 together, we get negative 16. Now we just have an equation to solve for x. So if we divide both sides by 2, we're going to find our x value is going to equal negative 8. Now we have to find our y. So it's up to you to determine which equation you think would be easier to work with. I think I'm going to choose the bottom equation, and here's where I use substitution to find my other variable. I'm going to take this negative 8 and I'm going to substitute it in for x in one of the equations to find my y. So when I replace x with negative 8, I will have negative 8 plus y equals negative 5. Then I need to solve for y, so I'm going to add 8 to both sides, and I will end up with my y value of positive 3. Now my final answer, because remember we're looking for where these two lines intersect, so we're essentially finding a coordinate, an ordered pair xy. So I put my x term first in parentheses, negative 8, comma, my y term is 3, and I'm just going to put little fancy things around it so that it stands out, because that's my final answer, negative 8, 3. Okay, we're only going to do one more example because, again, this is review, so I'm hoping that this all comes back to you pretty easily. So for question 2, we have y equals negative 6x minus 3 and y equals negative x plus 2. Normally, we would see these in standard form, y equals mx plus b, and we would decide to graph them. But since it specifically said to solve algebraically, we can't choose to graph, so we're going to do, in this scenario, the substitution method. Now, in the substitution method, in order to start substituting, you have to make sure that at least one of your equations already has a variable alone. Whether that be x or y, it doesn't matter. Here, we have two equations where both y is alone, so to substitute, we're going to take one of the equations, so negative 6x minus 3. Since that's equal to y, I can substitute it in for y in the other equation. And what that's going to look like is I'm going to have negative 6x minus 3 on one side of the equation and negative x plus 2 on the other. Now we just have to solve for x. So it doesn't matter where you choose to move the x's or the numbers. I know a lot of people like to put the x's always on the left, so we'll just go ahead and do that. So if we want to move the x's left, I'm going to have to add x to both sides. And in the same step, I can move the negative 3 to the right-hand side of the equation by adding it. So I will end up with negative 5x on the left, positive 5 on the right. And now, just to get x alone, all I have to do is divide by negative 5, and I end up with my x value of negative 1. Now, to find my y, I can choose either equation, whatever I find to be easier to work with. I think I'm going to choose the bottom one. And remember, I have negative 1 as an x, so I'm going to substitute that negative 1 in for x in one of the equations. And to do that, I'm going to have y equals, there was already a negative sign attached to that x, so I'm going to make sure I write that out in front. And in the parentheses, I'm going to replace x with negative 1. And then when I solve this, a negative times a negative is a positive, so y is going to equal 1 plus 2, which means that y is equal to 3. And when I put these two things together, I will end up with my final answer of negative 1, 3 as an ordered pair. And that is my solution. That is where these two lines are going to intersect. And that's going to conclude your notes for today. But if you have any questions or if you need more practice with this, feel free to reach out. I can create another video or I can work with you directly.